Okay, so for this video, we are going to discuss May, June 2022 and paper 3-2, okay, which is pure mathematics 3. Okay, so let's have a look for question number 1. Right, so for question number 1, they want us to solve this equation and then given the answer in 3 decimal places. All right, so let's start how to solve. Let's start to solve this equation here. Okay, so first of all, I think there are a few different ways that we can solve this. One of the way is you can try to group all the ln together at one side, and then you leave the term without the ln at one side. This is one method. Or you can change all the equation, all the terms here with ln, also can. All right, so for me, I'm trying to group all the ln together. So I bring the ln over, I'm having negative ln 3 and it is equals to 2x. So ln A minus ln B, I can combine them, become one fraction. And it is equals to 2x. So we are generally using the law, right? Where ln A minus ln B can be written or simplified as ln A over B. Okay, all right, then after that we are going to bring the base of the ln over. So the base of ln is e, and therefore we are having e power 2x. And for the left hand side, we left only this fraction. Right, so now we are going to move everything together and we try to group all the e2x together. So I'm having 3 multiplied with e2x. You can assume that e2x is an apple. So you're having 3 apples here. So 3 apples, 1 apple here. And if I bring the 1 apple over, it will become minus e2x, right? So 3e2x minus e2x, I'm having 2e2x. Okay, so if I continue further, I bring all the number to one side where I get 3 over 2 and I take ln both sides so that I can get the value for x. Okay, so very easily you can see that ln e is actually a 1. So on the left, I can bring the 2 over where eventually I will get ln 3 over 2 divided by 2. And I have to correct my answer to 3 decimal places, right? So the value for x that I get here should be 0.203. All right, so this is how we solve the equation. Okay, by grouping all the ln to one side, then the number to the other side. So this is how we solve it. So the answer is 0.203. Okay, so if we are interested to use another method where we try to change all the terms with ln, then it will look something like this. So this is the original equation again. Okay, so 2x, if I want to change it become ln, right, I should add a ln e with the 2x because ln e is a 1, so that I didn't change the pattern or the equation. All right, so I'm having 2x ln e. And now 2x can be bring back, become the power. So I'm having ln e power 2x, then plus ln 3. So you can see that every single term here, we are having ln already. So I can combine 2 lns on the right together where I will have ln, then 3 multiply with e power 2x. So again, from this step to this step, we are using the law again, where I have ln a plus ln b. It can be written as ln a multiplied with b. Okay, so when we do until this step, you can see that both sides also got 1 ln. Okay, you can cancel off the ln, and hence you get this equation now. All right, so you can compare and have a look where I really get the same step with this one. So you continue to solve and get the x following the same step here. All right, so these are the two options where you can try to solve the equation that involve the ln. Either you bring all the ln to one side, you keep the term without the ln to the right, or you can change all the terms with ln, then you cancel off the ln and simplify. Alright, so this is how we solve question number 1. Okay, so question number 2. Right, so we are having this equation and they want us to solve for theta. Right, for this equation, right, generally we can see that we are having a double angle where we're having cos 2 theta and also with cos theta. Alright, so for this question, to solve it, we have to change the cos 2 theta become cos theta first, where we have to use double angle formula and to simplify the whole equation. Right, so for the double angle formula, we are going to use this one, where it is provided in the formula booklet. So cos 2a, I'm going to use the 2 cos square a minus 1. Alright, so I will expand this, I will use this double angle formula in our solution. Okay, so why do I need to choose 2 cos square a minus 1 as an option for this question? It is because of we are having the cos theta also in the question. So I would like to change all the terms or mostly of the terms, right, with this equation with cos theta. All right, so let's start the solution. So we are having 3 cos 2 theta equals to 3 cos theta plus 2. So like what I mentioned just now, I'm going to apply the double angle formula. So I'm having 2 cos square theta minus 1 and then equals to 3 cos theta plus 2. Okay, so multiplying the value, I'm having 6 cos square theta minus 3 equals to 3 cos theta plus 2. And continue from here, I will try to rephrase everything. And I think I will get the quadratic equation. Alright, I think this is a quadratic equation that I will get. Okay, so I try to solve the equation, the quadratic equation, either by using the quadratic formula, okay, and see whether you get an answer or not. So to get the quadratic formula, negative b, right? So I'm having 3 plus minus b squared. So b squared is a 9 minus 4 ac and divided by 2a. Okay, so from here I'll get two different values for the cos theta. So the first value for cos theta I get is 1.196484724, where definitely I need to ignore this part of the solution because we won't get any solution from here. Alright, when we press cos inverse 1.19, we'll get a math error. Okay, so another value of cos theta that we get, right, should be equals to negative 0.6964847243. Okay, so for this question, generally we are going to find out the answer for theta. So first, I try to get the basic angle first. So if I press cos inverse, the value here without the negative, right? So the basic angle that I get is 45.9. And now I'm going to get the value for the theta. So again, refer to the domain that they give us, right? The range of theta that they give us. It should be theta from 0 until 360. So that means I have to go through all the 4 quadrants. For all the 4 quadrants here that we go through, I'm looking for cos negative, which is second and third quadrant. To get an answer for second quadrant, it should be 180 minus the basic angle. And for the third quadrant, the answer should be 180 plus the basic angle. Right, so if I simplify these two answers, I should get 134.1 degree and also 225.9 degree. So these are the possible answers for theta that we have for this equation. Okay, so question number 3. Alright, so we are having the polynomial px, it is given like this. And they tell us that, okay, px is divisible by 2x minus 1. So the word divisible means no remainder. That means the remainder is equals to 0 for the word divisible. Okay, all right, and then when the px is divided by x plus 2, then we are having the remainder 5. So generally for this question, we are going to apply the factor theorem and also the remainder theorem. Okay, so first of all, we know that px is given as ax power 3 plus x squared plus bx plus 3. Okay, so first information that I'm having here is this one. So px is divisible by 2x minus 1, where 2x minus 1 is a factor, right? Which means that if I substitute the value half into the polynomial, I will get the value 0 because there's no remainder. So remainder equals to 0, or according to the factor theorem, it is equals to 0. Alright, so substitute the x with all the half. Alright, all the x with the half. So I'm having 1 over 8a plus 1 over 4 plus 1 over 2b plus 3. And I get a 0. Okay, so I try to rephrase my equation and try to solve it. So I need actually second equation to solve for the a and b, because it's in one equation I'm having two unknown, right? So I try to rephrase it nicely first. So I'm having a equals to negative 4b, then minus 26. This is the first equation that I get from this information. All right. Okay, then now for the second equation that I can form, I can use this information now. Px is divided by x plus 2, then the remainder is a 5. Therefore, from here, I know that if I try to substitute the value x equals to negative 2, I will get a remainder 5, so it is equals to 5. Alright, so this is the remainder theorem that we have. And now we're trying to put in negative 2 into all the x. And the equation that I get for this part will be negative 8a plus 4 minus 2b plus 3 equals to 5. And then I'm having a equals to negative 1 over 4b plus 1 over 4. Alright, so after I get these two equations, I try to solve them simultaneously to get the value for a and b. So I let 1 equals to 2. So if you let 1 equals to 2, you're having negative 4b minus 26 equals to negative 1 over 4b plus 1 over 4. Okay, try to put all the b one side. And eventually I will get a b which is equals to negative 7. If the b is equals to negative 7, you try to substitute it back into either a first equation or second equation, then your value of a that you will get is a equals to 2. Okay, so this is how we get the value for a and b by applying the factor theorem and also remainder theorem. Question number 4. Okay, so for question number 4, we have the equation of a curve and it is given like this. Then we know that the curve has one stationary point in the interval from 0 until pi over 2. So find the x-coordinate for the stationary point and then give the answer correct to 3 significant figures. Alright, so when they're looking for stationary point, right, we have to link this by using differentiation, the dy dx. Okay, so we are having our equation here, y equals to cos power 3x, so I write it like this. So cos x power 3, and then sine x square root, that means I'm having sine x power half. So for equation y, we are having the product for two functions, right? Cos power 3 and also sine half. Therefore, to apply the differentiation, I have to use a product rule. So for the product rule is, we try to differentiate the first bracket, copy the second. So differentiate the first bracket here, I'm having 3, then cos x power minus 1 become 2. Differentiate the bracket inside the bracket, I'm having negative sign. So this is how we differentiate the first bracket, and now I need to copy the second bracket. So copy the second. Then plus, okay, then we do the other way around, where now I should copy the first bracket. So I just copy the first bracket first. And I differentiate the second. Differentiate the second bracket, half I put it in front, copy the bracket, power minus 1. And after that, I will need to differentiate the thing inside this bracket, differentiate sine x, I have cos x. Okay, yeah, so it looks like quite long. And if possible, we can try to simplify this whole equation first. Okay, so for first term, I'm having negative 3. Then I have cos square x. Sine x multiplied with sine x power half. I will have sine x power 3 over 2. That means 1 plus half, so you get power 3 over 2. Okay, so for the second term here, I'm having half. And then if I try to simplify, I'm having cos power 4x. And then sine x power negative half. Okay, all right. Then next one, if we want to get the stationary point, generally we need to let dy dx equals to 0. So I let it become 0. And then to solve this equation, generally what we can do is we try to factorize out all the terms that we can factorize. So as an example, I can factorize out the cos power 2. I can also try to factorize out the sine x with a smaller power. So if I try to factorize out the cos square, I'm having cos square. And then factorize out the sine negative half, I will have square root of sine x as the denominator. Okay, so after I factorize out the terms already, I simplify the first term. So cos square disappear. I'm having negative 3. So I just copy negative 3. And then for this one, right, you try to take 3 over 2 minus the negative 1 over 2. Because you have to think away, sine power something, when I divide by power half, right, I must get back 3 over 2. So if you try it, try to simplify this one, it should be sine square x, sine x squared or sine square x, right? Okay, then for this part, I take out the half, I keep the half, cos power 4, take out cos square, I still have cos square. This one I take out, totally have nothing. So this is how we simplify our equation here. Okay, then now we are trying to solve for this whole equation to get the value for x. For this part, if I try to solve for the value of x, right, I will realize that my answer does not belongs to this part, does not belongs to 0, does not belongs to, does not belongs to the range. Okay, from 0 until pi over 2, because you can see that no equal sign is included. If I try to solve this equation, I might get a value 0, right, where 0 is not included. So I ignore this part. So I will focus on this part of the equation to get a solution. Right, so if I rewrite it, I will have negative 3 sine square x plus half cos square x, and it is equals to 0. Okay, so I have sine square and cos square. What I plan to do is like I try to change it become tangent, and then from there I can solve it. Alright, some students they might want to change all this become everything with the sine or everything with cos also can. They are using the identity sine square plus cos square equals to 1, then they change the equation, also no problem. Alright, so for what I plan is I want to use tangent. Alright, so I move all the things one side here, then eventually you can see that I get actually equation that involve tangent, which is tangent square equals to 1 over 6. Okay, so I take square root. So when we take square root by ourselves, we need to include the plus and minus sign. So I'm having plus and minus 1 over 6. Alright, okay, so from here, if I try to further simplify it, I will need to press for the basic angle. Okay, I should try to get a basic angle, and then I have to go through the quadrant. Alright, okay, so again, before we get the answer, right, let's have a look for the range again. So this is from 0 until pi over 2. That means it is in the first quadrant. So I only need the answer in the first quadrant. So to get this answer, generally is very straightforward. You just need to take tangent inverse square root 1 over 6. So please make sure that your calculator is in the radian mode, and you can get the answer in the unit of radian easily, where it should be 0.388. Alright, so this is how we solve this question. Okay, so please make sure that if you try to factorize out the dy dx before you can continue to solve it. Right? Okay, so question number 5. They want us to sketch a suitable pair of graphs show that this equation has one real root. Right, so to sketch a pair of graph, right, generally we are going to sketch two graphs here. The first one is y equals to ln x, and another one will be y equals to 3x minus x squared. Okay, so to sketch ln x, I think it is quite simple and straightforward. And then for this equation, generally, it is a quadratic parabola. You can see that it is a quadratic curve, right? It is a parabola because of x squared. And then for x squared, it should be a U shape, but when you are having negative x squared, okay, the negative here actually tells us that we are going to have an N-shaped parabola. All right, okay, then if I'm having the x, I can factorize the x and I get 3 minus x. So from this factorization form, I know that the x-intercept for this parabola will be x equals to 0 and also x equals to 3. Okay, so from here we know all this information. We are having the parabola, okay, which is the N shape because of the negative, and also when we try to factorize it out, we can see that the x-intercept is actually x equals to 0 and also x equals to 3. Okay, so now we can start sketching the graph. Right, so I'm having a 0 here. Okay, I will have a 3 lah. I will label it later. Then I want to draw the N shape of the parabola now. So I will have something like this. Okay, so this is a 3. And of course, if you want, you can extend it. For this part, you can extend it. It will go down. Okay. Alright, so if you can try to label it clearly, where y equals to 3x minus x squared. Alright, then if I want to sketch y equals to ln x, so for y equals to ln x, generally it will pass through the 1. Okay, so the y-intercept will be the asymptote from the negative part, and my ln x graph should look something like this. So this is actually y equals to ln x. So from here, very clearly that we can see there's only one intersection point where it tells us that there's only one real root, okay, for these two graphs. Right? So we should make a suitable conclusion. So you can write it in this way. One intersection point can be seen. Okay, and therefore, there's one real root. Okay, so this is how we solve part A. Alright, then now let's proceed to part B. Okay, so for part B, they want us to verify by calculation that the root lies between 2 and 2.8. Okay, so to prove, okay, to verify by calculation, we are going to use the sign change method. So to get sign change method right, first of all, we should try to change this equation. We have to move all the terms to one side so that it becomes a function. All right, so for me, I will move the ln x to this side, to the right hand side, and I will have 3x minus x squared minus ln x. So this is how my function looks like. So function fx is equals to 3x minus x squared, and when I move the ln x to the other side, it becomes negative ln x. Okay, so after I get a function, only I substitute in the value. So I substitute in the 2. So I'm having 3 times 2 minus 2 square minus ln 2. And I get I get 1.31. And if I substitute the value 2.8, the answer that I get should be a negative value. So negative 0.470. Alright, so no matter how you move the equation, right, as long as you substitute the value, you should get one positive value and one negative value. If you change it to the other side, that means you should have negative value here and positive value here. It depends on how you move the terms to get a function. Alright, but no matter how, your final answer should be one positive value and one negative value. Alright, so once you get one positive and one negative value already, then you can make a simple conclusion where you can write in this way: sign change can be seen. Okay, so between f2 and also f2.8, and therefore the roots lies between these two values, between 2 and also 2.8. Okay, so this is how we verify that the roots lie between the 2 and also 2.8. Okay, then now let's proceed to part C. Okay, so for part C, this is the iterative formula given, and then they want us to find out the roots are correct to 2 decimal places. And then each iteration up to 4 decimal places, right? Okay, so by looking at this iteration formula given, right? Okay, so we need to start from the first value, the initial value. Initial value is not given in the question, so you can try to choose the initial value that you want. So for your information, the value that usually I suggest will be according to the previous part of the question when they ask us to prove for sign change or what, right? So I will try, if can, we will try to use all these value, either value 2 or either value 2.8 or any value between 2 and 2.8 if you want to start. So this is a small suggestion, right? Okay. So for me myself, I'm using 2.8. Right? Okay, so when I get 2.8, I need to substitute the 2.8 into my equation. Okay, so substitute 2.8 into the equation. I'm having 3 multiplied with 2.8, then minus ln 2.8. If you try to press the calculator, then we will have 2.7148. So this is my value for x2. And then if I want to get the value for x3, substitute 2.7148 into the iteration formula again. So from there, I'll get 2.6731. Okay, so to ease the process of calculation, right? So maybe we can use the calculator to help us. All right, then let's say we try x4. So to get the x4, substitute x3 into the iteration formula. So in our calculator, right, we can actually type in the formula. So you can see that we are having this one where it is 3x power n, then ln xn, right? So we try to key in the formula here, square root 3x. To get the x, you click alpha, then close bracket, then minus ln x, so ln x. Okay, so this is my iteration formula in general. Okay, and now I want to substitute this value 2.6731 to get the x4. So you can press calculate, CALC. They are asking you what is the value of x that you want to key in. So you can key in 2.6731, 4 decimal places, and you type in equal sign. So when you press the equal sign, you get 2.6526. So for this answer here, you put in 2.6526. Okay, then continue to get the next value. Alright, so for the next value again, you straight away key in or click calculate, CALC, and then key in the value for your x4. So your x4 is 2.6526. And I press equal sign. And this is the next value that I get, 6424. So I'll get 6424. Right. So I will get 2.6424. Okay, so again, I want to get the next value again. So maybe you will ask, when should we stop? So we have to try until the 2 decimal places answer are repeated. Okay, so here you can see 2 decimal place answer are not repeated yet. Okay, so you have to continue for the calculation. So again, I click in calculate and then 2.6424. And now you can see that the value that I get is 6373. So type in 0 or 2.6373. Okay, so seems like 2.64 and this one is also 2.64. Seems like repeated already, right? So usually for my practice, I will continue for a few more times to confirm that this is my correct one answer. Okay, so I continue with x7. Okay, so again, I try to type in, calculate, and then 2.6373. So the next value that I get is 6348. Okay, so 2.6348. All right, so you can see this one is 2.64, 2.64, and it becomes 2.63 again for two decimal places. So that means it is not constant yet. It is not fixed yet, not consistent yet. So you have to continue until it's consistent. All right, so I still need to continue for x8. Okay, key in 2.6348 now. All right, so calculate 2.6348. Okay, so I get 2.6336. So again, 2.6336. Okay, double check again. If you have a look for this x7 and x8, right, both two decimal place answer is actually the same, which is 2.63. Then again, I want it to be confirmed. I want to confirm that this is my correct answer. Then I continue again for another time. Okay, so I need to key in 2336 for now. So calculate again 2.6336. So this answer now is 2.6330. Okay, so 2.6330. Okay, so again, if I double check the two decimal answers, two decimal places answer for my iterations, right? These three are having the same value, which is 2.63. Of course, if you want it to be more safe, right, you can still continue with one or two iteration. Right, so for me, usually if I see that, okay, I have three iterations and they are all same, then I can conclude that the root is actually equals to 2.63 for this equation. Okay, so usually when we are having two times of repetition in the two decimal place answer, right, to me it is not secure enough. I will prefer to maybe continue with one or two more iteration, okay, to confirm that the root is what we get. Right, so for this example, this one is two iteration with 2.64 and then the three with 2.63. So I assume that maybe for the next one also 2.63. If you want it to be more secure, definitely you need to try again. Okay, try for one more iteration. Okay, so the root for two decimal places for this question will be 2.63. Then for all the terms, right, for all the iteration that you write out, please make sure that it is written in 4 decimal places. Okay, so this is how we solve question number 5. Okay, so we come to question number 6. All right, so we are having the variable x and y satisfy this differential equation. And then they give us one information here where y equals to 0 and x equals to 0. Okay, so they want us to solve the differential equation, obtaining the expression for y in terms of x. All right, so first step to solve the differential equation, generally you need to separate all the variable first, where we can try to group the variable y on the left and then the variable x on the right. So before I separate them, for this e power y minus x, I can write it become e power y, then multiply with e negative x. Okay, so I want to keep all my x on right hand side and then all the y on the left. So when I move the y over, I'm having 1 over e power y. And I'm having dy here. And then for dx, I will bring it over also to the left, to the right hand side. So I'm having e dot e power x dot e power negative x dx. So you can see very clearly that we now already separate y to the left and also all the x variable to the right hand side. And now I can put the integration sign. All right, so we can proceed with the integration. Okay, but for this part, for the right hand side, right? Generally, if I want to integrate this particular function here, I need to apply integration by part. Okay, so before that, maybe I need to find the answer for integration by part first, where x is the algebra, right? So x belongs to algebra and also e belongs to exponential. All right, so it follow the Liates rule, L-I-A-T-E. For those higher group, we'll make it as u. For the lower group, we'll make it as dv. dv, right? Integrate dv. Therefore, from here, I will let u, the higher group is algebra, right, equals to x, and then I will let dv equals to the remaining term where I'm having negative e negative x dx, and I need to put integration sign for both sides, right? So for u equals to x, I need to apply differentiation. So I'm having du over dx equals to 1. And then for this part, I'm going to apply integration. So this is actually a 1. So integrate 1, you get v. Integrate e negative x, you have negative e negative x. So for the constant plus c here, I'm not going to add it in this part. I will complete every integration, only I will add in the constant term. All right, so from here you can see that this is what we have when you want to apply the integration by part. This is a preparation, and now we can apply the formula where we're having u dv equals to uv minus v du. So this is a formula for integration by part, and I'm going to apply it on our right hand side here. Right, so I will substitute this value, okay, this formula answer into our right hand side. So let's start now. When I want to integrate e negative y, okay, so integrate e negative y, I'm having negative e negative y equals to, and now I want to apply the integration by part formula. So uv, so you have a look here, u is x, v is negative e power negative x. So uv, eventually I will have negative x e power negative x. This is uv. Then minus integration sign of v du. So again, v is this one, where it is negative e negative x, and my du here, du is equals to dx. So I put a dx. Okay. And now in my integration, in my solution here, right, you can still see the integration sign that we need to apply integration for one more time. Right, so I apply integration for another time, where integrate e power negative x, I will get back e power negative x divided by negative 1. So usually for us, right, I will straight away write it out as the answer where negative e negative x. And there's no more integration sign here in our solution, so I will need to add a constant term at the back, so which is a plus c. Okay. All right. And from here, if I try to simplify everything, because all the terms here are having negative sign. All right. So if I want to make our calculation easier later, so I will just multiply the whole equation with a negative sign also, so that all these terms become positive sign. And then the plus c, although since it is still a constant, so I will assume that the negative affect the c inside. All right, so I'm not going to change the sign here. Okay, so this is our solution, the general solution, and we need to get the particular solution when we need to find the value for c. Okay, so it is given that x equals to 0, y is also equals to 0. So substitute into this equation here, e power 0, you get a 1. X0, the whole thing is 0 here, then this one is also a 1. So from here, you can see that our c is actually equals to 0. So if we rewrite everything again, I'm having e negative y equals to x e power negative x plus e power negative x. And if they want us to simplify everything, express y in terms of x. Okay, so how can we express y in terms of x? First of all, maybe I want to factorize out the e power negative x first. And after that, maybe if I want to make the y as the main object, then I have to take ln both sides, right? So if I take ln both sides, the negative y can pull in front. Okay, because it is a power. So after I apply the ln for both sides, I can make it as a constant in front. Okay, so on the right, I also take one ln here. If you want, you can separate lah. You can actually try to separate the ln again if you want, but for me, I don't think that it is needed lah. All right, I can just leave my answer in this way, where my y is equals to this equation. Right, so this is how we solve this differential equation, and the process involved is actually the integration by part on this right hand side here. Okay, so this is what we have for question number 6 part A. And now let us proceed to question number 6 part B. Okay, so now they are saying that find the value of y when x equals to 1, giving your answer in this form, a minus ln b, where a and b are integers. Alright, so now let's recall what is what's our solution. So just now our solution is y equals to negative ln and then e power negative x plus 1. Okay, so we are given that when x equals to 1, which means we need to substitute the x equals to 1 into our equation here to obtain the value of y. Okay, so I'm having e negative 1, then multiply with a 2. Alright, I need to try to rephrase my answer here into this pattern. Okay, so how can we simplify it? Alright, so first of all, I will have this ln e negative 1 plus ln 2. Okay, so from here to here, actually I'm applying the idea where when I'm having ln a multiply with b, I can rewrite it become ln a plus ln b. Okay, so this is what I apply the properties of the logarithmic function that I apply. And after that, for the negative one, I can put it in front. Ln a is a 1, so I didn't write it out. And then plus ln 2. And if I multiply the negative inside, I will have 1 minus ln 2. So it is exactly exactly the pattern they want us to show. Alright, so my value of y will be equals to 1 minus ln 2. This is how we get the value of y. Okay, so come to question number 7. They give us a curve equation, and they want us to show that the dy dx equals to this expression, right? Okay, so for this equation, generally you can observe that y and x is quite impossible to be separated clearly. So we have applied implicit differentiation. Okay, so I'm having the original function where x power 3 plus 3x squared y minus y power 3 equals to 3. Okay, so let's start the differentiation terms by terms. First one, it is x power 3. After the differentiation, I will get 3x squared. Then plus, now for this one, the second term here, I'm having 3x squared y. So 3x squared y, you can treat it as a product of two functions. Maybe the first function is 3x squared, and the second function is actually the y. Okay, so now the product of two functions here, we have to apply product rule. So for product rule, if I want to differentiate 3x squared, I will get 6x. Then I copy the second bracket, which is a y. Then plus, now I need to copy the first function where it is 3x squared and differentiate the y. So when I differentiate the y, I will have dy dx. I have a 1 and also dy dx. Okay, then for the last term here, I'm having negative. Differentiate y power 3, I will have 3y squared. And of course, I need to include the dy dx at the end. Okay, then equals to 3. So 3 is a constant. After you differentiate, you'll get a 0. Okay, so just to take note that this part is actually we have to apply the product differentiation, differentiation by using the product rule. So this is the answer after we apply the differentiation using product rule. Okay, then now we have to try to group all the dy dx at one side and then all the other variable on the other side. Okay, so if I try to observe my answer, right, my answer is having y squared minus x squared, where I need to move this to the other side, this one also to the other side. So I'm having 3x squared plus 6xy equals to 3y squared dy dx minus 3x squared dy over dx. Okay, I can simplify the factor 3 here, right? Everything has a 3 and it's a factor of 3, the factor of 3. So I can simplify them straight away, where I'm having x squared and then 2xy equals to y squared minus x squared, and I factorize out the dy dx at the same time.
Okay, so from here, I think our answer is very obvious. So if I keep the dy dx on the left, then I try to rephrase everything again, then I will actually get the answer that they want us to show. Okay, so this is how we get this dy dx by using the implicit differentiation concept. All right. Okay, then now we can proceed to part B. So for part B, what do we have here? Okay, so for part B, they actually want us to find the coordinate of the point on the curve where the tangent is parallel to the x-axis. So when they mention that tangent is parallel to the x-axis, means that the gradient of tangent is equals to 0. Okay, so this is the important information because from this phrase or this sentence, they actually tell us that the dy dx is equals to 0. Okay, so what is the dy dx that we have just now? So for dy dx that we have just now, so I need to recall the answer again. Okay, so what is the answer for the dy dx just now? It will be x squared plus 2xy divided by y squared minus x squared. So if I let dy dx equals to 0, the y squared minus x squared bring up, I also get a 0, right? So I only have x squared plus 2xy equals to 0. Okay, then before I solve for it, right, I can factorize out the x, and I got x plus 2y equals to 0. And I'm having 2 points here, 2 solutions here where x can be equals to 0, and also x can be equals to negative 2y. Okay, so please take note that these two are two different points. All right, so you have to find out two different points or two different coordinates for these two values. All right, so let us start with x equals to 0 first. So when x is equals to 0, what happened or what is the value of y that I can get? So you have to substitute x equals to 0 into our original equation. So again, what is our original equation? You can recall back. Our original equation is something like this: x power 3 plus 3x squared y minus y power 3 equals to 3. So this is my original equation. Substitute x equals to 0 into my original equation. This first term is 0, second term is 0. I left only negative y power 3 equals to 3. So if I try to simplify or get an answer for this part, right? So y is actually equals to the cube root of negative 3. Okay, so from here we actually get the first coordinate. When x equals to 0, y is the cube root of negative 3. And now we need to find the second coordinate. So second coordinate, the information is x equals to negative 2y. Yeah, so I will try to substitute it again. Okay, so when x is equals to negative 2y, what happened to my equation? So I try to substitute negative 2y into this whole equation here. Okay, so x equals to negative 2y. So negative 2y power 3. I will have negative 8y power 3. Substitute x squared by using negative 2y. I'm having 4y squared. So 4 times 3 is 12. I'm having 12y power 3. And for this last term here, no need to substitute anything, just copy, and it is equals to 3. Okay, right, so from here we can continue and to further simplify it. So if I try to simplify, negative 8 plus 12 minus 1. So I'm having 3y power 3 equals to 3. And from here, very obvious, I can get the value for y, which is equals to 1. Okay, so when your y is equals to 1, substitute back into this part, and you will get x equals to negative 2. So this is actually our complete coordinate. All right, so we are having two coordinates here. The first one is in this color, and the second one is in purple color. All right, so you can write out the coordinates that they want us to find. The first one is actually 0 and also the cube root of negative 3. Another one will be negative 2 and 1. Right, so this is how we try to get the point when the dy dx is equals to 0. Okay, so we come to question number 8. Right, so we are having this rational function and they want us to express this rational function into partial fractions. Okay, so if I double check at first, I will see that the numerator, the degree of the numerator is a 2, degree of the denominator is a 3, right? So you can see that this is a proper fraction. So for proper fraction, you can straight away separate them, become the partial fraction. All right, so I'm having x squared plus 9x divided by 3x minus 1 and then x squared plus 3. So I can rephrase it, become the partial fraction with a over 3x minus 1 and also b. Okay, so we are having the quadratic factor, right? X squared plus 3. So since this is a quadratic factor, therefore our numerator should be bx plus c. Okay, so I want to make the whole denominator disappear. So I multiply the whole equation here by using the denominator. Okay, so if I try to simplify everything, I will get something like this. Okay, so to get a value for a, b, and c, right? Okay, so for the first one, I will refer to this bracket. I want to make this bracket become 0. So if I let this bracket become 0, I will get x equals to 1 over 3. So I will let x equals to 1 over 3. Substitute 1 over 3 into this whole equation here and get and solve it, right? So 1 over 3 is 1 over 3 square. So 1 over 3 square is 1 over 9. Then 9 over 3 is a 3. So 1 over 9 plus 3. On the left hand side, I will have 28 over 9 equals to substitute 1 over 3 into the coefficient for a. Okay, so 1 over 3 square, I'm having 1 over 9 plus 3, which is also 28 over 9. So I'm having 28 over 9a. Then for this part, if I substitute this value 1 over 3 here, this whole section or this whole part here will be disappeared because it belongs to 0. Okay, so very easily we can get the value for the a, which is equals to 1. Okay, so after I get the value for a, the second value that I want to take is x equals to 0 because I can make this part become a 0. All right, so I will let x equals to 0 now. Okay, if I let x equals to 0, the left hand side will be equals to 0. So 0 plus 3 is a 3, right? So 3 times 1. 0 times b is a 0. I have a c here. 0 minus 1, I get a negative 1. So from here, I'm having 0 equals to 3 minus c, and I can get the value of c. So c is actually equals to 3. Okay, so now I already get the value for 1 and 3, and next I can use any value that I never used before so that I can find out the value of b. So I will let x equals to 1. If I let x equals to 1, substitute it into this part, I'm having 10 on the left. And then 1 plus 3 is a 4. 4 times a. So it's a 4 times 1 is a 4 also. Then plus, just copy the plus. B times 1 is a b. C is a 3. So b plus 3. Substitute 1 here. So 1 times 3 is a 3. 3 minus 1, you get a 2. Okay, so I get an equation like this. If I try to further simplify it, I will have b plus 3 actually equals to 6 divided by 2, which is a 3. And from here, you can see that b is equals to 0. Okay, so once you get all the value for the constant a, b, and c, then you can rewrite your answer again into a partial fraction form, where x squared plus 9x divided by 3x minus 1 and also x squared plus 3 will be equals to 1 over 3x minus 1. b is a 0, right? So you need to write it out, and c is a 3. So 3 over x squared plus 3. Okay, so this is what we have for the partial fraction. Okay. All right. Then now let's proceed to the next part. So for this next part here, they want us to apply integration. All right. So it is the definite integral from 1 to 3 for the function of fx. Okay, so let us start again. So I'm having 1 and 3. So since just now they already asked us to make the rational function into partial fraction, right? So I will integrate from the partial fraction pattern as well. So 1 over 3x minus 1 and then plus 3 x squared plus 3. Okay, so first of all, I'm trying to integrate this bracket. So 1 over 3x minus 1, I'll get ln 3x minus 1 divided by the differentiation of 3x minus 1, where I get a 3. Of course, I need to put in the limit of 3 and 1. Then for the second term here, 3 is a constant. Usually I will take it out from the constant. And then, okay. All right, so for this denominator, I write become x squared plus square root 3 squared. Okay, so again, I will rewrite again. So I'm having 3, which is a constant. I will take it out, and I'm having integration of 1 over x squared plus square root 3 squared. Okay, so to integrate this part, right, generally there's a formula that we can apply. Okay, the general formula is if I'm having the integration of 1 over x squared plus a squared, the answer that I get generally will be 1 over a tangent inverse then x over a. So this is a formula that we're going to apply, okay, for integration for this expression. Okay, so now let's put in the value 1 over 3. The 3 here is a constant. Usually I prefer to take it out. Then I substitute the value 3 into the x here. I'm having 3 squared, which is 3 is a 9. 9 minus 1 is 8. Substitute 1 into the equation here. I'm having ln 3 times 1 is a 3 minus 1 is a 2. All right. Okay, then for this part, I can start the integration now. So my a here is actually square root 3, right? So after the integration, I will have 1 over square root 3, which is 1 over a. Okay, then tangent inverse x over a, so x over square root 3. And of course, I need to put in the limit for 1 and also 3 here. Okay, this part I can further simplify already, where I'm having 1 over 3 ln 4. Then plus 3 over square root 3, I get a square root 3. For tangent inverse, substitute the 3 inside, I'm having tangent inverse 3 over square root 3 minus tangent inverse 1 over square root 3. Okay, so now what I need to do is like just try to further simplify everything into the most simplified answer. So 3 over square root 3 is actually a square root 3 again. Okay, the 2 I can put in front, become 2 over 3 ln 2. Okay, so for tangent inverse square root 3, right? If you can just press the calculator and help you. Alright, so if you don't want to use the calculator, then you can just imagine that we are having a standard triangle, right? I'm having 1, 2, square root 3 here, where this is actually 30 degrees, is pi over 6, and then this one is pi over 3. Okay, so tangent inverse square root 3, I will have a value which is pi over 3. Tangent inverse 1 over square root 3, I will have the value which is pi over 6. Alright, so if I try to simplify all the terms here, right? Okay, pi over 3 minus pi over 6, actually I'm having pi over 6. Okay, so simplify again. I can rewrite become square root 3 over 6 pi. Okay, so I no need to change it become decimal number because for this question, they request to have the answer in exact form. So I don't know whether you see the keyword or not. Okay, exact form. Therefore, our final answer, we have to we have to leave it in this way. All right, okay, so this is how we actually solve this question number 8. Okay, question number 9. We are having the line L and M with the vector equation. So this is a vector equation for L, this is a vector equation for M. And then they tell us that L and N intersect. They want us to show that 2b minus a equals to 4. Okay, so first of all, when the vector equation or when the lines are intersect, right, that means the vector equation should be equals to the other vector equation. So I'm having -1 plus 2 lambda, 3 minus lambda, and also 4 minus lambda. Okay, so I will make it into a column vector form for this vector equation, and they are equals to the vector equation for the line M. So for the line M, I'm having 5, 4, 3, then plus A mu plus B mu, and also plus mu. Okay, so this is what I have for the vector equation L equals to vector equation M because they are intersect to each other. Alright, so first of all, I will want to try to make the lambda and mu disappear so that I can get the equation of 2b minus a equals to 4. Okay, so there are many ways for you or for us to complete this part. So generally, I try to rephrase all my equations slowly and get rid of the lambda and mu to get this. Okay, so first of all, I will look at the last equation here where I'm having 4 minus lambda equals to 3 plus mu. Okay, so for me, if I try to rephrase it, I will have lambda equals to 1 minus mu. And this is my first equation. Okay, so the second equation, I'm using the second one, where this one. Okay, so I'm having 3 minus lambda equals to 4 plus b mu. Okay, and now, because just now we are having the lambda equals to 1 over mu, right? And now we try to get rid of lambda. So to get rid of lambda, I'm having 3 minus lambda, I substitute by using 1 minus mu, right, equals to 4 plus b mu. Okay, and I'm having 3 minus 1 plus mu equals to 4 plus b mu. Alright, so if I try to simplify further for everything, I will have mu 1 minus b, and it is equals to 2. Then further rephrase it, I'm having mu equals to 2 over 1 minus b. Okay, so this is my second equation here. And now the third equation that I'm going to use is the first one. Okay, so let's have a look. We are having -1 plus 2 lambda equals to 5 plus a mu. Okay, so again, what we want to do now is we actually want to simplify and get rid of all the lambda and mu. So as an example, for 2 lambda, right, I will substitute the 1 minus mu inside first. And then for the mu here, I will substitute by using the equation number 2. I'm having 2 over 1 minus b. Okay, so for this part, I'm having -2 mu, right? So again, for the 2 mu, the mu, I will substitute it by using this equation again, so that I can get rid of all the mu and lambda in my equation. Okay, all right. So if I try to rephrase everything again, so I'm having actually -4 over 1 minus mu equals to 5 plus 1, which is a 6, minus 2, I get a 4. So I'm having a 4 here. Okay, so sorry, I'm having a 4 here, and then plus 2a divided by 1 minus b. So to make the 1 minus b disappear, I multiply the whole equation by using 1 minus b. So I'm having -4, then 4 multiplied with 1 minus b, and then plus 2a. Okay, so from this step onwards, we just need to further simplify the equation so that we can get the answer. That's it. Okay, so 4b minus 2a equals to 8, and therefore we get 2b minus a equals to 4. So this is the equation that they want us to show. All right, so for to get this equation right, I believe that there are many different ways for us to get this equation. So my one is the most basic one. That means I try to rephrase all my equation here so that I can get rid of lambda and mu slowly from the last one. Okay. All right, so this is what we have for part A. And now let us proceed to part number B. Okay, so for part B, now they give us another information where L and M are perpendicular. Okay, so what will happen if let's say the L and N are perpendicular? Okay, so L and M perpendicular means that the direction of L and M multiply with each dot product, right? The dot product of the direction for L and N, it is equals to 0. So where is the direction for L? So the direction for L is actually this one. You can see that it is negative, sorry, it is 2, -1, and -1. Then the direction for the line M is A, B, and 1. Okay, so we're having A, B, and also 1. So the dot product for these two functions or these two vectors should be equals to 0 because of the two lines here are perpendicular to each other. Okay, so from here we will start the solution. Okay, so just now we already know that the direction of the line L, okay, so the direction of the line L, which is 2, -1, and -1, dot product with the direction of the line M, which is A, B, and 1. They are perpendicular to each other. Therefore, I know that the dot product between them is a 0. Okay, and then apply the dot product. 2 multiplied with A, you get 2A. -1 multiplied with B, you get -B. And the last one, you get -1. And it is equals to 0. So from here, you can get 2A minus B minus 1 equals to 0. Maybe you can treat this as a second equation. And still remember what is the first equation that we proved in the first part. So in the first part, we actually proved that 2b minus a. Alright, so 2b minus a is equals to 4. So from here, maybe I want to substitute a equals to 2b minus 4 to solve the equation. Alright, so I will have 2, and then a, I will put in 2b minus 4. This is a lah, right? So minus b minus 1 equals to 0. Okay, so from here, very easily, you can get b equals to 3. And if you get b equals to 3, then you also can get the value for a very easily from here, where a is equals to 2 times 3 is a 6 minus 4, which is a 2. Alright, so this is how we get the value for a, which is equals to 2, and also the value for b, which is equals to 3. Alright, so this is what we have for part B. Okay, so if we proceed further to part number C. Okay, when A and B are having these values, right, they want us to find the position vector of the point of the intersection of line L and also the line M. Okay, so to get the position vector of this point, right, the point of intersection, we actually have to use back either this equation to get the position vector or this equation to get the position vector. Alright, so because we get the value for A and B, right? So I think it's quite easy for us to get A, B, and mu. So I'm going to use this formula to get the position vector. Okay, so please take note on this part. This is the position vector formula. Okay, I need to substitute all the value for A, B, and mu to get the answer. Okay, so from here we will start. Okay, so to get the position vector, right? So like what I told you just now, we are going to use the formula. Do I need to rewrite again? So we are using this actually. So 5 plus A mu, and then 4 plus B mu, and also 3 plus mu. Okay, and then just now we already get the value for A, which is 2. And the value for B, it is actually a 3, right? So these are the information that currently we are having. And also important info in part 1, where the mu is actually equals to 2 plus, 2 divided by 1 minus B. So all this information are actually part of the solution in part A and also part B. So I just retrieve everything here so that you can refer to it. Okay. So they want us to find the position vector of the point. So to find the position vector, generally you need to substitute A, B, and mu into this equation. So I know that A is equals to 2, right? Then what happened to the mu? So mu is actually 2 divided by 1 minus 3. Okay, so 1 minus 3 is negative 2 lah. So 2 divided by negative 2, you get a negative 1. So the mu is actually negative 1. Okay, then 4 plus b. B is a 3 multiplied with negative 1. And then it will be 3 minus 1, right? Okay, so if you try to simplify this part, generally you're having 5 minus 2, which is a 3, 4 minus 3, which is a 1, and then 3 minus 1, it is actually equals to 2. So if you want, you can rewrite your position vector into the ijk form, where it is 3i plus j, then plus 2k. All right, so here we ended our chapter 9. Our question. Okay, so question number 10. U is a complex number. So this is a complex number denoted by U. Then U is the root of the equation. So this is the equation, and we know that U is the root. So that means we substitute this value into the equation, we should get the correct equation. All right, it is equal to 0 on the right. Okay, so find the value of k. So to find the value for k, generally we just need to substitute the root into the equation, and from that we can get the value of k. All right, so before I substitute the value, right, because I can see that we are having x power 3 here, so I need to find out negative 1 plus square root 7i power 3 first before I can substitute it into the equation. Okay, so power 3 means I'm having this same bracket for 3 times. Okay, so first I try to expand the first 2 brackets first. Okay, so negative 1 multiplied with negative 1. So I'm having 1. Okay, after that, negative 1 multiplied with this. So we are having negative square root 7i. Next term, we are having you're having positive square root 7i multiplied with this again. So I'm having again negative 7 square root 7i. Okay, and the last term is this one. Okay, so 7 square root multiplied with square root 7, I get a 7. I multiply with 1, I get I squared, so it should be 7i squared. So since I squared is negative 1, right? So eventually, if I simplify, I'm having negative 7 here. Okay, so before I further expand it, so I will try to simplify it first. Okay, so if I simplify this first bracket here, I'm having negative 6 minus 2 square root 7i. Then multiply with negative 1 plus square root 7i. So please take note also, this answer is actually the x squared or negative 1 plus square root 7i squared. Okay, all right, so I have to proceed further so that I can get a power 3. So negative 6 times negative 1, I get a 6. And I'm having negative 6 square root 7i plus 2 square root 7i. Okay, and the last one I will get 2 times 7, which is 14. Okay, then 14 plus 6 is 20. Negative 6 plus 2, I'm having negative 4 square root 7i. So this is the answer for negative 1 plus square root 7 power 3. Okay, so since I already get all the information that I want, so I will start to substitute it into the equation so that I can get the value for k. Alright, so my equation is actually this. Okay, so 2 x power 3. X power 3 means the root power 3. So the root power 3, the answer I get is this one. So I will just put in 20 minus 4 square root 7i. Okay, then plus 3 x squared. So the x squared is what I underline here. Okay, my x squared is negative 6 minus 2 square root 7i. Okay, then plus 14x. So 14x means that my root value is negative 1 plus square root 7i plus k. K, I don't know what is it, and I let it equals to 0. So from here, I just need to make sure that I simplify my equation correctly. Okay, so expand everything. Okay, so from here you can observe that negative 8 square root 7i, negative 6 square root 7i plus square root 7i. For this square root 7i, right, you cancel off everything for the I. So there's no more imaginary part here. Then for 40 minus 18 minus 14 equals plus k equals to 0, right? So if you move all the number to the other side, you will see that your value of k is actually equal to negative 8. Okay, so this is how we solve and to get the value for negative of the value for k, which is a negative 8. Okay, all right. Then now they want us to find the other two roots of the equation for part number B. Okay, so we already know that 1 negative 1 plus square root 7i is one of the root, right? And if we try to observe the coefficient of the polynomial, everything is a real number. So when you're having the coefficient of polynomial, which is a real number, it also denotes that the conjugate for this root is also one of the root. So that means negative 1 minus square root 7i is another root. So this is the first root given in the question. By using the rule here, all the coefficients are integers. So we know that the roots come in conjugate pair. So the conjugate complex number negative 1 minus square root 7i is also one of the root. Then now we want to proceed and get the third root. Okay, so before we can get the third root, I need to find out the factor of the polynomial. Okay, by using this one and also this one, these two roots. Okay, to form the factor, generally I'm using the concept that we learned in quadratic before, where the x squared can be written as sum of roots x plus the product of root. Okay, so I just copy the x squared first. Sum of root, I'm having negative 1 plus square root 7i, negative 1 minus square root 7i, and then I'm having an x outside. And then the product of roots means that negative 1 plus square root 7i, negative 1 minus square root 7i. Okay, so I try to simplify all these terms here. Okay, I'm having 2x. Then for this part, if I try to expand it, I'm having a plus 7. So in short, my quadratic factor for this equation should be x squared plus 2x plus 8. Okay, so to get the last root, we just need to try to apply the long division. Okay, so my original equation is this one, 2x power 3 plus 3x squared plus 14x minus 8. And then the quadratic factor that I'm using is x squared plus 2x plus 8. So for the first term here, I need to multiply with 2x so that I can get 2x power 3. 2 times 2 is a 4. So 4x squared, 8 times 2 is 16. Okay, so minus. Okay, so from here I'm having negative 1. So when I have negative 1, you can see that I can complete this long division without the remainder. Okay, because actually this is the quadratic factor that we tried to find just now. Okay, so now you already get this quotient. So if let's say I want to find out the roots, the third root will be actually from this quotient here. Alright, okay, so the other roots that they want us to show generally is like this. There's another one which is negative 1 minus square root 7i. Like what I mentioned just now, it should be in conjugate pair, right? So the second root is actually negative 1 minus square root 7i. And another one, you can get it from the quotient. So 2x minus 1 equals to 0. Therefore, your x is equals to half. Okay, so this is what we have for part A. Oh, sorry, part B. Okay, and now let us proceed to part C. Alright, so for part C, they want us to sketch the locus that represent the equation modulus z minus u equals to 2. So if we write out in detail, it should be z minus modulus, the u is actually negative 1 plus square root 7i, and that equals to 2. Okay, so generally this will be a circle where the center is negative 1 and square root 7. The radius is a 2. So if we try to sketch out the diagram, right? Okay, of course you should try to follow the ratio and using the same ratio for the x and also the y-axis, or the real axis and also the imaginary axis. Okay, so if I try to label, right, by common sense, you should see that the circle that we draw should be something like this. Okay, right. So I will just draw the circle first. Okay, this is not a nice circle, sorry. The circle will cross the x-axis, sorry, the y-axis, it will not touch the x-axis, by the way. Okay, it will look something like this, but my circle is not good enough. So if can, we try to draw it as good as possible, so that later when you want to use the diagram, right, to do some calculation for the greatest and largest value or whatsoever, it is easier. Sorry, it is really bad, so maybe I can redraw it again. Okay, so by right, this is what we should have. Okay, let's assume that this is a circle, and actually your center is here. Okay, where this is negative 1 and this is square root 7. Okay, and then the radius here, everything is a 2. So if this is negative 1, right, so this one will be a negative 3 and it is at a 1. Okay, so generally this is the arc diagram that you should have. Alright, and this is u. Okay, alright, and now for the third part, for the fourth part, part D. For part D, they want us to determine the greatest value of argument z. Okay, for points on this locus, giving your answer in radian. Okay, by generally you have to have a look for the diagram that we draw if I want to get the greatest value of argument z. So the greatest value for argument z generally is argument z minus 0 plus 0i, where our reference point to sketch or to measure the argument is actually 0 and 0. So let's have a look. 0, 0 is here. Okay, so how can it form the greatest argument, okay, with the locus z? So if you try to use a ruler to move here and there, right, generally you can see that at this point, okay, we will get the largest value of lambda. Largest value of argument, which is the theta. Okay, and this is a tangent. You can assume that this is a tangent, okay, of the between the center to the certain point here. But definitely I will not know what is the certain point here. I just want to show you that this is a 90 degree, and then we can actually have a triangle here. Okay, all right, so this triangle, blue color one, is very useful for us to calculate the greatest argument. Okay, so for your information, the greatest argument is actually from here to this line. This is the greatest argument. Okay, so to find out this greatest argument, generally we are having two parts. The first part is this one. We calculate this one. The green color is actually the argument of u. Green color is actually the argument of u. And after that, this purple color inside, okay, I can use the property of the triangle, okay, the trigger ratio of the triangle to find the purple color angle. So the green color plus purple color, I will get the black color, okay, which is the largest argument or largest theta. Okay, so this is our process to find the answer here. Okay, all right, so I will show my step here. Okay, let's try to find the green color part first. Okay, wait, so let me show it like this. So I'm having the greatest argument. Okay, so what is the step that we should follow? Okay, green color. So green color is actually the argument of u, argument of the complex number u. So the argument for complex number u, it is in the second quadrant, right? So I will take 180 minus the basic angle. So the basic angle is actually tangent inverse square root 7 over 1. I ignore the negative, so square root 7 over 1. So this is the argument for the complex number u. Then besides, I also need to add in the purple color one. So for this purple color angle, you know that this height here is a 2. Okay, the radius, this is a radius, which is a 2. And then the hypotenuse is the modulus of mu. Correct or not? Yeah, so what is the modulus of mu? Modulus of u. We can find here also. Okay, wait. So if I'm using this theta, if I want to find this theta, generally it is sine inverse. Opposite means a 2, right? The radius divided by, okay, so divided by the hypotenuse. So hypotenuse again, like what I mentioned just now, it should be the modulus of mu. So the modulus of mu is, the modulus of u is 1 square or negative 1 square plus square root 7 square. Okay, so if I try to rephrase everything, okay, so 1 plus square root 7, actually I will have square root 8. Okay, and then by pressing calculator and add all the steps here together, my greatest argument is actually 2.72 radians. Okay, so to make sure that you can get the answer correctly, right, when you want to press the calculator for this answer, your calculator, it will be the best in the radian mode, your calculator, so that you can get the answer correctly, which is 2.72 radians, correct to 3 significant figure. Okay, all right, so this is how we solve the question number 10. All right, and here we ended our paper 3-2 for May June 2022. Okay, so thank you very much for watching this video.